Okay, good afternoon. Welcome to, what is this?
Math for Kids number 15.
Math for Kids number 15. Okay, we're gonna.
We didn't write that down.
Yeah, I know, I forgot to. We're gonna do something a little bit different just for the next week, just for fun. We had a problem last week that was something called a continued fraction, and he wanted to learn more about continued fractions. So we're gonna do a whole week just talking about continued fractions. And you know what? Continued fractions used to be taught in school.
I wonder why they're not anymore.
Yeah, I don't know. It's actually kind of sad. There's some things that used to be taught in school that are not taught anymore that are really neat things, and continued fractions are really neat. So we're going to talk about continued fractions, and let's first do a real simple example, just so we can show what a continued fraction is. How about 1 plus 1 over 2 plus 1 over 3? Okay? This is just going to be a simple idea. So continued fractions are something like this. And I could go on for a lot longer if I wanted to. I could say plus 1 over 4 plus 1 over 5, something like that. But we're just going to do this. We're going to stop here just to make it nice and simple. Okay. So, do you know what 2 plus 1/3 is? So we start at the bottom of a continued fraction and work our way back up. Do you know what 2 plus 1/3 is?
It's 2 and 1/3.
It's 2 and 1/3. Yeah, that's right. Do you know how many thirds 2 plus 1/3 is? You can draw it out.
Well,
you know how to make thirds? Yeah, good job.
The peace symbol, something.
Yeah. 1. Don't stand in front of the camera. Okay.
And then, so this is... No, whoops.
Go ahead. Okay, good job. So how many thirds is 2 and 1/3?
Here's 6 thirds and 7 thirds.
Right. So 2 plus 1/3 is 7 thirds. So we can write this as 1 plus 1 over 7 thirds. And you know, the other way, besides counting, by drawing out little pies and counting, so we can do just a little arithmetic. 2 plus 1/3 is the same thing as 2 over 1 plus 1/3.
You never got the common denominator.
Right, we got to get a common denominator. So you multiply this one by the denominator, 3 over 3. And you multiply this one by this denominator, 1 over 1. So we get 6 thirds plus 1/3. And 6 thirds plus 1/3 is?
6 thirds plus 1/3 is 7 thirds.
7 thirds. Great job. Okay, so now we have to evaluate this funny expression up here. 1 plus 1 over 7 thirds. So 1 plus 1 over 7 thirds. Now, what do you do when you have 1 plus 1 over a fraction?
Well, you take the 1 over off and then flip the fraction.
So this becomes 1 plus, what does 1 over 7 thirds equal?
It's 3/7.
3/7. Awesome. 1 plus 3/7. And do you know how many sevenths 1 plus 3/7 is?
Well, 1 is 7 sevenths.
1 is 7 sevenths. Good job.
So, it's 10 sevenths.
This is just 10 sevenths. Okay. So we can have a funny, sorry, not too funny. 10 sevenths isn't that funny of a number. Does 10 sevenths make you laugh?
No.
No? Are you sure? 10 sevenths, I don't think 10 sevenths would make anybody laugh. But 10 sevenths actually is a neat number because you can write 10 sevenths as 1 plus 1 over 2 plus 1 over 3. That's equal to 10 sevenths. Okay, so we just learned how to go this way for a continued fraction, how to take this sort of funny expression and write it in the way that we know how. But let's go the other way. Okay, why don't we, do you want to just pick a number?
Yeah, pick a random number.
Well, I want you to pick two numbers actually. I want you to pick a fraction, and I want you to pick the top bigger than the bottom.
Okay.
Okay? don't say 1/2. Make sure the top's bigger than the bottom.
How about 64 on top and 32 on the bottom?
Ah, okay. You know what? That's not a bad one to start with, but the problem with 64 divided by 32 is it's just 2.
That's not very complicated.
Yeah, that's not very complicated.
Then how about 64 over 48?
64 over 48. Okay.
Good one to start with. Big numbers.
Well, it's big numbers. Why don't we start with something that's a little bit smaller, so it's not too crazy.
How about 32 over 14?
32 over 14. Great. 32 over 14. Well, the first thing we notice is the top and bottom are both divisible by 2.
Yep.
So this is 2 times 16 over 2 times 7.
Yeah.
So instead of writing 32 over 14, we're just going to write 16 sevenths. Okay, is that all right?
Yeah.
Okay. So we're going to write 16 sevenths.
Yeah, because this is 16.
That's the same as 32 over 14. Okay, so 16 over 7 equals... What happens when you divide 7 into 16? What do you get?
Well, 7 can only go into 16 2 times.
2 times, right, and then you go 14. And what's the remainder?
The remainder is 2.
Remainder is 2. So this 16 over 7 is going to be equal to 2 plus 2 sevenths. Okay? And that's what the remainder 2 means. It's 2 plus 2 sevenths.
Yeah.
Okay? So that's our first step. Now remember, we're going to try to make this look like something like 1 plus 1 over 1 plus 1 over 1 plus. Okay? So now what we do is we flip it. So this is 2 plus 1 over, what on the bottom flips up to be
7
halves?
7 halves.
7 halves, right. So this is the same as 2 plus 1 over 7 halves. Now what is 7 halves? What do I get when I divide 2 into 7?
Well 6 halves is 6 halves is 3.
6 halves is 3, so
it's 3 and 1 half.
it's 3 plus 1 half, right. Good job. 3 plus 1 half. Okay, hey, so we're done. So 16 sevenths is 2 plus 1 over 3 plus 1 over 2. That's pretty neat. Okay. Now, you ready for something really crazy?
Yeah.
Something that you've never ever seen before? Well, we can do a little bit of practice on this, but I'm going to show you some really neat stuff. Now this is really advanced. Back over there, back up just a little bit. This is really advanced. Now this is something that I'm not even sure you know what it means. But let's say I wanted to solve an equation like x squared plus 5x plus 1.
Does this have anything to do with continued fractions?
Yeah, it does actually. Let's say I wanted to solve x squared plus 5x plus 1 equals 0. Okay? What happens if I put the number 1 into here? What's 1 squared?
It's just 1.
Plus 5 times 1 plus 1 equals 0. So this is 6. Does 6 equal 0?
6 does not equal 0.
6 does not equal 0. And more importantly, does 1 plus 5 plus 1 equal 6?
1 plus 5 plus 1, no.
It equals 7. But also, fortunately for me, 7 does also not equal 0.
And
okay. So 7 does not equal 6. Okay. Alright, let's say we wanted to solve this. And we have no idea how to solve this. We don't know how to find when this equals 0. But you can do something really neat.
I wonder how advanced this is.
Yeah, I goofed up with my example. I wanted to say x squared minus 5x plus 1 minus, sorry, x squared minus 5x minus 1 equals 0. Okay, sorry about that. So I'm going to say that x squared equals 5x plus 1. And then I'm going to divide both sides by x. X squared divided by x. Remember, x squared is x times x.
Yeah.
So when I divide by x, I just get an x. X equals 5 plus 1 over x. Okay, now this is a little complicated, and I don't expect you to understand this all, but I just want to show you one neat example of continued fractions.
Yeah.
Okay, so I know the solution to this equation, x squared minus 5x plus 1 equals 0. We're calling that x. And we know that x has the property that x equals 5 plus 1 over x.
When x.
Okay? So look at this. X equals 5 plus 1 over x. Well, what is x? X is just 5 plus 1 over x. So I'll just cross this x out and say 5 plus 1 over x. Hey, what's x?
Yeah, this thing is going to go on forever.
Right, let's extend it all the way over here. Tell me what x is?
X is 5 plus 1 over x.
5 plus 1 over x. Hey, what's x?
X is 5. This is going to go on forever.
5 plus 1 over x. And we can just keep going down, so we're going to have this descent. We're going to have 5's going all the way down. You know how far? Is that ever going to stop? Because we're always going to have an x.
Endless.
It goes on forever. So we have this crazy number here. 5 plus 1 over 5 plus 1 over 5 plus 1 over 5 all the way down to infinity is going to be the solution to this equation. Wow.
And that's going to equal 0.
Right, it's going to be some number. This is some number. We don't know what this is. We have no idea how to evaluate this.
You can't evaluate it.
No, actually, you know what? You can.
Whoa!
Really? Can you believe that? I might teach you how to do that. This is going to equal some crazy number. And whatever this number is, when you square the number, subtract 5 of that number, and then subtract 1, you're going to get 0. So this is how people started studying continued fractions. They started noticing these really neat patterns. So we're going to study a little bit about this week. You excited to do that?
Awesome.
Okay.
And by the way, what are the homework problems?
Yeah, well, we won't worry about putting the homework problems on the video this week, but we'll do some homework problems. Don't worry. All right, good job.